Hello, thank you for joining me in this Global Mapper tutorial. I have version Global Mapper 15 and we will start by opening with some data files. You can take data from the internet, download online imagery, topo terrain maps. Okay, and we have here MapQuest, OpenStreetMap, NAIP color imagery, USA topo maps, United States elevation data, world imagery, world street map, world topo map. We have some premium content which you need to pay. Or we have country data, Brazil topo maps, GeoFly Poland orthophotos, geological maps for Australia, Canada, Spain, France, Great Britain, and Nordic SGU, North America and UK. World imagery, high resolution, Intermap Europe, World 30 meters them, Landsat 7 again, NAIP World imagery, Poland maps, lawn covering, so Korean land cover on NLCD VCF3 cover, terrain data Amsterdam, Intermap Europe, Intermap USA, SRTM worldwide, United States elevation data. We have topo maps, Brazil topo maps, USA, world topo maps, world topo maps, USA data, Intermap USA, NAIP again, NLCD US land parcels, so they're categorized for United States, or cloud imagery, US weather date radar mosaic, Intermap Europe, Landsat 7, MapQuest, OpenStreetMap, SRTM for 3-arc resolution, world imagery, world topo street map. So for example, if I select SRTM, this would be a source, and then I could get the entire data source bounds, or I could get within 1 mile or 1 kilometer of address, and then I put here, for example, my hometown, and see if that works. You have to click connect, and then it will try to find the data that you are looking for. So this is Cluj-Napoca, Romania, and that is the SRTM. You can see here to the left, it's the height or the altitude relative to the sea, and displayed on the screen with various colors. You can see the relief. And then here you have a scale. If you want to import just regular data, you open data file, and then I need to go to where my data is, and I do not currently have, I believe, anything to do with Romania, but I could get, let's say, from England, and then either this or this should give me data that contains a particular address, and then I can get a rectangular box based on that particular point. So the shape files are loading, and you can open like that any kind of data, including raster. Okay. Now if you have multiple layers imported, you go to Open Control Center, and if you just want to zoom to select to one of them, let's zoom to this one which has less points. Okay. If you double click it, you have options for them to, we will go through this in a later video. Okay. You can go to zoom to selected feature, and now Global Mapper will take you to that particular feature. As you can see, there are quite many, especially since we have 2 layers. If you click here on this, if you tick it, it's represented. If it's unticked, it's not represented. Okay, it takes longer to respond since it's a large file and my computer is not very fast. Sometimes I just get angry and I close the program and then start it all over again. I'll wait for a second now. It's my mistake that I uploaded 2 files which are quite large. And I'm also recording on this computer now, so it sucks basically. Okay, let me see if we can open the attributes table. There are some options here like join table, calculate attributes, but what I want to do is search. Also we can set what zoom levels it displays. So let's go through the options here. You can rectify if you want to move the layer's position or projection. So click on rectify. Okay, and then to rectify an image, usually zoom into the zoomed view of the image by dragging boxes and click on a control point. Repeat for the desired number of ground control points. Well, currently we don't have an image, but this is what it would look like if we did have an image. It would be posted here, and then here you can zoom in into this side of the screen, and you are able to put dots more precisely, and you have here as the reference image. Let's zoom into this. You can see here this screen, this rectangle. It will show us here sometime in the near future, but I think I'll just opt not to bother too much with this. So then I can also zoom in more. And if I had an image that was whose corner was here, then I would be able to place the point here as soon as the screen. Not the fastest of computers. It's running on an SSD, if that matters. It doesn't. Come on! Do your magic. Alright, so you'll be able to place a point here, for example, like this. It will tell you the source coordinates, and then you can put here the actual coordinates, and then add point to list. You name it as point 1, and then you put another point here. You add point to list. Alright, you have to make this a bit different, so right, and then you put the point here, which would be, let's say, 2 and 1. This is point 3. And then you put here, and you put the coordinates that it actually has, point 4. And then you'll just press OK. You can select also what the projection it is from a long list of projections. Or you can even load a projection from a file. If you have a .prg file, it will load that particular projection. Alrighty then. I could have chosen not to display it, and that would have been much better, because if you don't render an image or a vector file, then the system runs much faster. And then you have to select the datum. Okay, you need to know what datum to select, so be very careful with this. You can also add a datum. If you know the datum name, abbreviation, prime meridian, an ellipsoid that is based on, again you need to know this 100%, or you can add an ellipsoid in a similar manner. You need to know the ellipsoid name, semi-major axis, or flattening. Here you have to select from these 3 methods of transformation, and then how to shift it based on WGS. So this needs to be some values either with 2, 3, 4, let's say, and then 4, 5, 6. Okay? Okay. Well, we don't create now a datum. And then planar units, just leave it like this, okay? Don't bother. And then let's see if we select any of these. Okay, let me see. Let's say this one. Okay, it doesn't have any false listing. Let's go to something that I know that it has. Well, apparently this one doesn't. So, Poland has a central meridian scale factor, which is a factor to convert the data from which is farther away from the central meridian. And then the central meridian has a particular value, which is 19. That's basically the meridian number 19 starting from the central meridian in Greenwich, London, and then the 19th meridian is in Poland. False easting, this means that basically the central meridian has been moved 500,000 meters in a positive way. This is due to, well, together with the false northing, which is 5,300,000 meters more to the south. This will ensure that all the values within Poland are positive. This is what is needed to be done, so that when you have a large area, if you just place the central meridian inside in the middle of Poland, and then the central horizontal axis, which is, well, parallel to the equator, then you get values which are with minus and some values with plus, and then you can no longer make operations. So you need all the values to be positive. Okay, and just to press OK. If you want to delete any of the points that you think, oh well, actually I didn't put the correct values here, just press delete. Do you really want to delete? Yes. Okay. Or you can also, let's see, select all of them, shift all, and then you select the units. Should be here also meters or yards or feet, arc seconds. Then it's input how much values. If you want to just be by 1, all of the values will be moved. 2, 3, 3 here, from previously being 1, 1, 1, 2, 2. Sorry. Or you can also click apply. But in this case, we don't really care about this. Yes, I want to cancel. I just want to show you what other features there are, and I'll disable it so that it's no longer visible and therefore saving screen. Sorry about this. Okay, and then you can set what zooms the levels to be displayed at. Below a given map scale. Our current map scale, you can see it here, is 3,511,18,100. So I just want it to be displayed below 250,000. So now even if I tick it, it's no longer visible, unless I zoom in. Yes, as you can see at this value, it's visible. If I zoom out, no longer visible. Now it's visible, now it's not visible. This helps the computer perform faster if I just render whatever I need at a particular zoom level. Okay, shift. You can shift the selected layer's fixed instance or transform coordinates. This is similar to the shift that was previously mentioned in the georeferencing stuff, the projection. But we don't want to. If I want to shift everything a fixed distance, let's say I want to shift everything on the y-axis, latitude, or the longitude I want to shift, let's say 1000 meters. Perhaps we will notice a change here from wood end. Does it go somewhere? The change is very small. Okay, I need to shift them back. So minus 100 plus 100 meters. Okay. Right. Let's change them so that we actually see how much it is. We're not afraid of changes, are we? 10,000 meters. Let's see. Where does Earlwood go? Okay. It didn't move too much. Something's fishy here. Let's move him with 100,000 meters. It's 100 kilometers. Come on, Broadway, change. It didn't change. Well, this is not working properly. Anyway, right, then set view export projection to selected layer projection. We can export the projection if we changed something, but we didn't, so we can zoom to selected layers, but then again it will not be visible because the scale has changed, 4,352,000. We can group some layers in this, let's say data here. Okay, and we can put also this one here, I believe. We can group it with data. Okay. We can add a description if we want to change the name. Let's say points. And we can open it in Windows Explorer so we can see where it is located on our data structure, folder structure. Select all features in selected layers with Digitizer tool. The Digitizer tool allows us to go in, come on, zoom in. Alright, so if you have this selected, you cannot zoom in or out. You need to go here and zoom in. And now I can select some points. And I can do whatever I want. Later on I will show you. Okay. I'm not sure what this feature does. Text, set text file to display when opening file. You may need to read further about this because I'm not really sure. Okay. Allow feature selection from selected layers. We could disable this, so then we can no longer select features. This is useful if you don't want, if you're working a lot in this area and you just don't want to by accident to select features, then it's perfect. Then create workspace file from selected layers. You can just save a workspace. The workspace is similar to ArcMap. I don't know, document, or however you save in ArcMap. Let's say first work. Right, so now in the future we can come here and load workspace, and then we can see here our workspace. Basically, a workspace is a collection of shapefiles and images and data structures kept in one particular form. So it remembers everything from here. It remembers all the settings you've done. You don't need to do them again. You can create a map catalog. I'm not sure what this does too much, but I assume it's similar to data frame properties, data frame operation in ArcMap. I can't really say that for sure. You can create an elevation grid. Let's just click OK. Of course, you need fail to generate any elevation grid tiles. That's awesome. That's because we don't have 3D vector data, basically. None of our data here is 3D. If we had elevation points here, then we can go and create elevation grid from 3D vector data. Okay, you can calculate attributes. You can assign it to a particular column, or create new attributes. So what kind of data do we have here? F class, name, OSM, population. So let's say it's density, and we just divide the population by 1000. So from population divide 1000. This will be similar. You could also divide it probably by another attribute. So if you had here the surface as well, if you're talking about countries, of course, you can use a fixed value and just click calculate. It's calculating the attribute. You modified everything now. Well done. Let me see, how do I see this? I think it's not possible to see the attributes table. It should be possible, but I don't know how. You will probably see it where if you export this file again. I will show you in the future how to export the file. Okay, and then you can join tables. If you have another table that you want to join to this one, of course they need to have one column that is identical, both in the name and in the structure. And then you can create density grids. Okay, point count, for example, and search radius. Let's make it 1000 meters. Cells per radius, just I don't know, 5. I don't want cells per radius. Let's make it 5. Okay. Square kilometers. Okay. Specify bounds. Let's just make it so. Even when you export the file, you have this feature like how much do you want to export from it. So you can crop to selected feature, but there are no current any area feature selected, and then you can just all the data, which will be too much, or all data visible on screen. You can also drag a box, so just make it here. Hopefully it's enough, but we'll just leave it like this. Or you can import latitude, longitude, projection, whatever this is and whatever that is. Okay. Oh, my computer is running really slow today. I wonder why. Come on. Come on. Just do it already. Awesome. Alrighty then. So it gives us the density, if I understand correctly. But it's all in green, in blue. So what have I done here? I don't know. This is useful when you have a large number of points and search radius is smaller. Let's make it 100. I'll make it 1 here. I don't know. Okay. No, I think this is doing it for the entire system. I see. So here you have some colors changing because these points have been modified here. Okay. See there, wherever you have points, the density is larger, of course, because you have a point. And if you have multiple points here, density changes. It can get in theory up to 99 points. Let me see where it gets this value. Let's just zoom to select layers. You can zoom in with this. I know nothing. I'll just delete this. To delete is close overlay. Yes. Close overlay. Yes. And then we can create again. Let's make it to this zoom level. Density grid. And let me just measure something. So if you want to measure something, you just use this. This is called the measure tool. Okay. Let's see. It shows to the lower part of the screen is 36,000 kilometers. I don't know. Must be 34 kilometers here. And then if I want to go down, segment length is 27, total length 63. Yeah, I just care about 27. So they are in kilometers anyway. And then you press escape to close. Alrighty then. Okay, so let's make it to 1000 meters search radius, and then cells per radius. Let's make it number of samples. I can't really say this for sure what they mean, and it's difficult to know. Let's make it all data visible. Square area units, square meters. Density type. There are various options here. You need to read more about it. I'll just leave it to the default. And then let's make it a color ramp shader. Okay. Alright, so you can see this heat map basically. It's showing that here there are more points in the same unit area, and here are more points, and here there are less points, and here there's no point. There's no point in doing this. I'm just messing with you. Okay, dokie. This is quite fun. It looks quite nice. It's like modern art. Except it isn't. Okay, and I don't need this now. And you can see here how you can add the density. And B box covered edges, create area features from the selected layer bounds. Just create rectangular bounding areas for the selected layers or compute. I don't know, this does not apply here, sorry. Okay, you can split. This is quite cool. So you can select the attribute value to split this layer into new sub-layers. So for example, the population, I can just split it based on population under a value, I hope, and population over a value. As soon as the computer recognizes that I'm a human being asking it to work faster. Which will never happen, of course. Come on! I haven't got it all day, you know. No tengo todo el día. Je n'ai pas tous les temps de la jour. And let's say in Dutch as well. Ik heb geen. How do you ever say time? Okay, I've done something stupid, so I'll stop now. I'll get back to you when the system recovers. So the system recovered quite fast after this, after I stopped the recording, just because the recording takes a lot of space. So now we have basically divided one feature, 4 features. For some reason there are values which are 1, 8, 10, and then there are 3 features with the same value, and then 2 features with 740, and then 2 features with 734, and then whatever they are here. Each different value, and now we have a lot of layers which we don't actually need for Allah's sake. So I will close overlay. Yes. No. Oh, I don't want to say it. Sorry. I thought you asked me only if I want to really close them, but apparently that's not what you did. Did ya? Did ya? Yes, Kitty, yay. Come on, close all the layers. Oh yeah, I have to go back to closing this. Pathetic. Okay, now it's closed. So now it's closed, obviously. Boom. Oh, sorry, that was Romanian. Okay, and now we can work on this file and see what else we can do. You can close all hidden layers if you have any hidden layers. You can hide all off-screen layers if you have any off-screen layers. I don't know what on-screen and off-screen mean. Let's select all on-screen layers. You can invert selection. If you've selected something, then you can just invert it. Let's invert selection. You've selected something else now. That's awesome. That's what we need. Reorder maps by description, resolution, location. I'm not sure what this does, so I'll not bother with that. You can move selected layers after another file, and then you can just move it there, which it already is there, man. Draw first, or draw sooner, or draw later, or draw last. Basically, if I draw this data point last, then it will be on top of points. But if I draw sooner, then